During the next session, we will learn about a new non-woven web formation process for 100% continuous lyocell fibers. Please let me welcome our next speaker, Ibrahim Sagerer-Foric, Project Manager of Global R&D Process Development at Lenzing, Austria.
Ladies and gentlemen, we have a problem. We have a problem with not renewable resources. We have a problem also with single-use plastic, and we have a problem with waste. How to deal with this problem? Lenzing is innovative by nature, and Lenzing is delivering and developing solutions, sustainable solutions for the textiles and for the non-wovens industry. My name is Ibrahim Sagerer-Foric, and in the next 10 minutes I would like to show you that the Lenzing web technology is a real sustainable alternative for the non-wovens industry. A real alternative should not be a compromise. A real alternative should give some additional advantages to the customer. Lenzing web technology is sustainable, but it is much more. It is the next generation sustainable nonwoven. It is a new platform for nonwoven product engineering. And we are exploring this technology. What are we doing? If we compare, for example, the spunbond technology, the melt-blown technology, spunlace and wet-laid, relative to each other in different categories, like is it possible to use renewable raw materials, the absorption properties, the mechanical properties, and also the question if the product is fully biodegradable or not. We can, for example, take a look on the wet-laid, and we can see that wet-laid is highlighted green because we can use pulp. Same is true for spunlace when we use cellulosic staple fibers. On the mechanical performances, we can see, for example, that spunbond or melt-blown has a very high tensile strength in wet stage. And melt-blown has very fine fibers, what can be very useful for a lot of applications like filtration. And finally, at the end of the life cycle of a nonwoven material, we have to talk about if the product is biodegradable or not to solve our waste problem and our problem with single-use plastic, for example. And the question is, it is possible to combine all the advantages of the existing nonwoven technologies into one technology. Let's mix, for example, a fully biodegradable product with very fine fibers, with very low basis weight, good mechanical properties also in wet state, good absorption properties, and let's use renewable raw materials. Finally, we will get Lenzing web technology. So Lenzing web technology is combining the advantages of different nonwoven technologies. Lenzing web technology is the next generation of sustainable nonwovens. We are using certified trees, converting wood chips into pulp and pulp into lyocell dope. Lenzing web technology is the direct web formation out of lyocell dope. And the product of the Lenzing web technology is a nonwoven roll good with a high variation of product properties. So how is this possible? If you take a look at our very detailed picture of the process, you can see that we are using a spinneret, a unique spinneret for the Lenzing web technology. We have a web formation area, so we have a direct web formation of the lyocell dope. We have a washing stage, that's the bucket. We have a hydro entanglement stage, and we have also a dryer, and finally a winder. What we can do in this process, we can either use one spinneret or multiple spinnerets. So we talk about either single layer products or multiple layer products. We can have same product qualities on different layers or different product qualities. What we can do is, with our spinneret design, change design parameters, and we can impact the mechanical properties of the filament and also of the product. We can also increase or decrease the primary air, what we are using to accelerate the filaments. We can increase or decrease the vacuum to impact the web density. And what we also can do is to increase the pressure or decrease the pressure on the hydro entanglement to impact the mechanical properties or the 3D structure of our nonwoven material. As a result, we get a really good alternative to plastic nonwovens because we have a nonwoven material made from wood and it is fully biodegradable. In between, we can change a lot of product parameters because we can change a lot of process parameters. To give you an example, on the left side, you can see something what we call merged filaments. So we can get either a very flat and crispy product or a product what has more a soft, flexible, and textile structure. We can change this online on our pilot line, and between this product and this product is approximately 5 minutes of setup time. So what is the status? We have a pilot line in Upper Austria with 1 meter nonwoven width. Here you can see some pictures with the wash line and with the winder of our pilot line. We are doing now a lot of process optimization because we have to answer a lot of questions on the technological side and also on the product side before going in the product engineering, application development, and then the final target is the commercialization of the Lenzing web technology. And if you have questions, we will be happy to discuss the potential of this technology also with you. Thank you very much.